Yes, thank you everybody. We are Team Janssen Pharmaceutica. Yes, next slide please. So we've decided to focus on dengue in Africa, mainly because there is not a lot of data available on dengue in Africa. When you look at this map from healthmaps.org, which contains data over the past 3 months, then you see a lot of cases reported in South America and Southeast Asia, but almost nothing reported in Africa. While if you look at how likely it is that there is a risk for dengue, then that doesn't match. So next slide. On the other hand, when you look at malaria, then you do see a lot of reported cases in Africa as well. So they do have a good system to report malaria, but nothing in place to report dengue. Next slide. And then this is also confirmed by trustworthy sources like the WHO, for example, saying that dengue cases are underreported. Many cases are misclassified as well. And a similar statement from the National Center for Bioinformation. Next slide. So where did we start off? Well, we found a paper of New Caledonia, which is somewhere close to Australia. And they found a lot of different factors that influence or have an influence on dengue. We took out 5 of them, which are actually the main factors that have an influence. And we did some, well, we in the end created a model based on those factors. There were a lot of other factors, and we started looking at those as well, but we didn't get that far. So next. So what was the plan? Well, first, validate what was done in New Caledonia on another country where we had data from. So we took Cambodia just because of the reason that we had some dengue cases reported and some information from Cambodia. And then the idea was to also apply that model to African countries to get a better idea of how many dengue cases there would really be in Africa. So, sounds easy. But then, yeah, and I have quite a few challenges on, slides on what are the challenges, or what were the challenges that we faced. So there was, yeah, previous ones still. So there was a lot of data in some cases. When you look at weather data, it's so much data that it was too complex for us to even start going into a lot of detail. But then for some other information, you don't find a lot of information. Next one. Then trustworthiness of data. We found a lot of sources, but then you also see differences in the different sources. So which data to use? Next, please. Then data cleaning, and we actually spent quite a lot of time on data cleaning as well, which was a long effort. We didn't prepare at all, I would say. We had some ideas, but we didn't prepare. So we had to spend a lot of time looking for data and also cleaning that data. Next, please. And then, of course, in a hackathon, it's a limited set of time. You have 36 hours, 5 persons. We did not have time to, well, we did not prepare, time or not. So time was the punisher. Next. And then another well-known guy. Well, when you can say a lot of things, but sometimes you also need to know what you're talking about, not like other people. And that's a challenge within data science. We have a smart team, of course, we have a smart team, but we didn't have data scientists, and I think that was lacking in our team. So next. So what did we do? And that's for you, Joris.
Okay, we actually looked at some data. We had the dengue case data from the database, but we wanted some demographic data which wasn't readily available. Yeah, okay, now a bit about our approach. We started now with modeling Cambodia. The idea was to model Cambodia and then apply this model to Africa. So in the end, our aim was Africa, but we spent the whole time in Cambodia actually. Well, we found a lot of demographic data in a census report, but we had to extract that from the report, so we spent a lot of time cleaning that data. And we had troubles linking the climatological data to, for example, the provinces in Cambodia, also because I don't think we have any people who are used to working with GIS or any of these systems. So next slide, please. So, okay, what we did do with our modeling approach, we used 24 provinces in Cambodia, which we divided in a training and a test data set. We did a model based on the log incidence of dengue So just the number of cases divided by the population, and we took the log of that to get it slightly normally distributed. We standardized all our predictors to improve portability. So if the scale is different, you could use in another country. And we used some modeling approaches. I hoped to try to use finally some big data manipulations or statistical methods, but unfortunately our database was only 24 provinces and maybe 20 predictors, so not really huge data, but rather small data. And in the end, we based our model on a simplified linear regression model. Okay, next slide. So that was what we predicted. We tried to predict the incidence, and from that, the number of predicted cases. Red are the training data sets, black are the test data. So we saw for the number of cases a good relationship between the two, even in the test data set, apart from one big outlying value, which has a true case incidence of 2,000 per year, and we predicted 500. So can we guess what it is? It's Phnom Penh, and we saw already in some of the previous presentations that big cities are quite different from the rest of the country. And then we prepared a visualization of our prediction. So it's kind of matching, but it's only, yeah, and that's Phnom Penh. So that's a much larger, smaller predicted compared to what was actually observed. So the idea is then to get these variables also for Africa, add climatological factors, and then apply the model to Africa and see where dengue cases are likely to occur. Maybe we can also add malaria data and see then the relative prediction of malaria versus dengue, and then focus the areas where you can do studies, epidemiological studies, or making awareness campaigns for the population to think really about dengue when they are getting a febrile illness. Thank you.